So we're going to look at the entire unit review for the comparing and scaling unit. So you'll see here, number one, write a fraction to represent the number of boys who chose football out of the total number of boys. Those are our two numbers that we need. I'm going to use two different colors here. So total number of boys, I'm going to make yellow. So boys total is right here, and number of boys who chose football is right here, 60. So that makes our fraction. So number of boys who chose football is 60 out of our total 225. That's it. That's all we have to do for this question. The next one wants a percent. If you want a percent, you actually need the fraction first of all the boys who chose football. That's the same fraction. So we're going to take this fraction, we're going to go to a decimal first by simply dividing the 60 by the 225 to get that decimal. So 60 divided by 225 is this 0.26 repeating. You can tell it repeats because that 7 at the end is really another 6 that has a 6 after it, and then of course it bumps up to a 7 if you were to round it. So what I do next is I do this number times 100 to get it into a percent, because that way I just see it. So this is equal to 26.6 repeating percent. It's about 27%, but that's a little bit inaccurate. 26.6 repeating is the most accurate way to write this answer, and we love accuracy in math. So that would be our answer for that one. The next one, ratio of girls. So we got a ratio of two things. I'm going to use some colors here. So ratio of girls who chose basketball. And then the other one is girls who chose soccer. So girls who chose basketball, I'm going to look for that in the table first. So girls who chose basketball is right here, 30. And then girls who chose soccer is 120. So that's our ratio. So 30 to 120. You can write a ratio many different ways. This is fine, or this is fine. If you're going to do simplest form like it asks though, I like fractions the best. Those make the most sense to me to simplify, but you can simplify any of these. It doesn't matter. So first thing I see is they both end in a 0, which means I can divide them both by 10, and that gives me 3 out of 12. And so already it's much simpler, but I can go a little bit step further because 3 is prime, which means I can only divide it by itself or by 1, and dividing by 1 wouldn't change it. So if I divide this by 3 and I divide this by 3, I get 1 over 4. So the simplest form is 1 over 4, which of course you could write just 1 to 4 with a colon. That's the same thing. Or 1 to 4 with the word 2. For the next one, which the following is the ratio of girls who chose football to boys who chose soccer. So girls who chose football is 10 to boys who chose soccer. Boys who chose soccer is 85. So 10 to 85, you can write it like that. You can write it like this. We look at what we have, and it's a fraction, 10 to 85 like that. The next one, this is one of the hardest ones on this page for sure. What's the following ratio is equivalent to number of boys who chose soccer to number of girls who chose soccer. So boys who chose soccer is 85. Girls who chose soccer is 120. So 85 to 120. I like this better actually as a fraction, even though the other ones are not fractions. To me, this makes more sense because if you're trying to figure out approximately equal, look at the decimals and pick the closest one. So 85 divided by 120 gives us about 0.7. So we got a little bit extra on there, but about 7/10. And if you look at the first option, that is 7/10. So 7/10 is equal to 0.7. So already these are pretty close. And the other ones are not going to be. If I do 2 to 5, that's 2 divided by 5, which is, if I do it on the calculator, it's 0.4, but 2 divided by 5 is 4/10. And then 6 over 1, that's just 6, dividing 6 by 1. And then 3/8, divide 3 by 8, and you get 0.375. So again, the closest option is what we thought it would be, choice A. So on to number 6. So 5 packs of gum cost $3.50. So what I would do first is I would fill in what you know for sure. I know 0 packs of gum are going to be $0. And then for me, going from 5 to 10 is pretty easy. I know how to double. So this is going to be times 2 right here. And $3.50 times 2 is just $7. So that goes right here. And then you might want to go, okay, from 10 down to 1. And this is just one way to do it. There's many different ways to do it. But you could divide this by 10. And 7 divided by 10 is just 7/10. So that's 7/10. And again, you could do this divided by 5 if you wanted to, from 5 down to 1. And then divide that by 5, you'll get the same answer. And then from there, we'll just count by 7/10. So if it's 7/10, I'm going to keep adding 7 on, but keep it in that tens form. So 1.4, okay, kind of like 14. And then 2.10, kind of like 21. 280, 350 we already have, 420, and then 490, 560. And what I'm doing every time, I'm just adding the 70 cents for every 1 pack of gum. So adding on the gum, adding on the price. For 9 then, it would just be this, again, plus 70 cents would be $6.30. Now when we go to make our graph, I'm going to pick the points that are the easiest ones to graph because this is going to be a proportional relationship, which means it's going to be a line. So 0, 0, 10, 7. I know exactly where that point is. That's exactly right here. It's 10 packs of gum. So it's 10 here. It's not 10 over here. That's $10 because that says that's the cost over here. I'm going to do one more. I'm going to do 5 and 350, which is right here. And that's all I really need. I'm going to use my straight edge. I'm going to line these points up with that straight edge. I'm going to draw a nice straight line like this. Then we got to think about arrows. What arrows make sense? Well, we can buy more than 10 packs of gum, so we can put an arrow over here, but not over here. Okay, we're not going to have negative packs of gum, so we're not going to go in the other direction. So just like that should be our graph. For part C, it asks for the unit rate. The unit rate in a coordinate form. So coordinates are always like this, 2 numbers with a comma in between, trapped in parentheses. The unit rate is always per 1. So our unit rate over here in our table is right here. So there's our coordinate. 1 pack of gum, because that X always comes first. This is the X, this is the Y. So the X comes first, and the Y was the price of 1 pack of gum. So 70 cents, or 0.7. Now for the equation. The equation here, you're going to use C for cost and G for number of packs. The way I think about that is, what does that 0.7 mean? That 0.7 means 70 cents per pack. So the cost is 70 cents per pack. You read the equation like you read a sentence. Cost is 70 cents for every pack of gum G. The operation for per is multiply, which you get in between these two by putting them side by side. So you don't need anything else in there. It's just 0.7 G, because that gets you the times G. I don't need to put the little dot there, but you can. It's the same either way. For part E, the constant of proportionality, that just means unit rate. Okay, and we just answered basically what that was. The unit rate is the only number you see in a proportional equation. It's just the 0.7, the 70 cents per pack. That's your constant that you're scaling by in this proportional relationship. For 70 packs of gum, there's different ways you can do this. If I know that 10 packs cost $7, I could use that. So 10 packs, $7, and go to 70 by making a proportion here. This would be writing and solving a proportion. Times 7 times 7. So X would be $49. Or we could do 70 times the unit rate, because each one is 70 cents, and 70 times 0.7 is $49. Either way, you get $49 for the cost of 70 packs, which is a different answer from part G. Part G is saying $70. So again, I can go back to any of the rates from my table. I'm going to use the 10 and the 7 because there's no decimals there. If I want to go to $70, that goes down here, and I don't know the number of packs, not parts, packs. This would be times 10, and this would be times 10. So our X would be 100 because 10 times 10 is 100. So 100 packs of gum would be $70. Definitely different answers here. If you put $49 for part G, how would that make any sense? How many packs of gum can you buy with this much money? You said $49? Makes no sense at all. For this coordinate here, again, the coordinates are always the X followed by the Y. So this is saying the X thing is 6, so the packs of gum are 6. So 6 packs of gum are, go to the Y thing. The Y thing is cost. So the 4.2 is the cost. So R, $4.2. And that's what that coordinate means in context of the situation, what we're actually talking about. For number 7 here, for the chocolatiness, we want the strongest flavor. Many of us just take these numbers and we just simply divide them, and that's not very helpful. So if it's 2 parts to 10 parts, let's always write a fraction first and put your labels on there, please. It makes it so much easier. 2 to 10, so many different ways to do this. What a lot of us do is just simply divide and you get 0.2, but you don't know what that means. And then you do 1 to 4, you divide that, you get 0.25, and then you just kind of pick one. But don't do that, okay? You want to think about what this means. It's 0.2 what per what. Get it back into a ratio. This is chocolate to milk. This is chocolate to 1 milk. So in both cases here, this is for one amount of milk, 1 part milk, and then how many parts chocolate. So you want the most chocolate, you want the most right here. So it's got to be recipe 2 because it has the most chocolate, because 0.25 is bigger than 0.2, because 0.2 is just 0.20, per the same milk, or for the same milk. Okay? Different way you could do this too, if this is 2 to 10, you could make that 1 to 5 by scaling it down. Then you could say, well, for the same chocolate, you could say that this one has less milk for same chocolate. So it's not always just the bigger number. In this case, the smaller number would be more chocolatey because it's less milk we're talking about. It's all about the context, all about the numbers and the labels. I mean, all about the labels, not just the numbers. There are more ways to do that. You can use percents, you can use all sorts of things, but that's just a couple ways to look at it. For this one here, it wants you to scale from 20 minutes up to an hour. So you have to know that 1 hour equals 60 minutes. And then you have to know, okay, well, 60 divided by 20 would be 3. So all we need to do is do 2/15 times 3, and you get 6/15. Okay, if you want to simplify that, that would be divided both by 3. You could write this as 2/5 or 0.4 of a mile in an hour. It doesn't ask you to do all that, but this is totally fine. You can also use a proportion, but you don't really need to. You can just kind of scale this one up. Whereas the next one, you need to. If you don't do this and it asks you to, you're going to lose some points. So a proportion is a fraction equal to a fraction. So half an avocado has 120 calories. And right away, I make that into my first fraction. Then how many calories, so over here, do 13 avocados have? So we don't know the number of calories. We have 13 avocados. So it says 13 is the avocado. So we have to go from a half to 13. And then use that same scale factor down here. So here's where it can be kind of tricky. You've got to do 13 divided by a half. And on a calculator, it can be hard to do because 13 divided by 1 over 2, mine actually does it correctly and it puts it in the right format. But you may need to type it in as 13 divided by parentheses 1 over 2. Otherwise, it may do 13 divided by 1 and then divide that answer by 2, which is a totally different number. Or use a decimal. We know that 1/2 is 0.5, so 13 divided by 0.5 to get that scale factor. Any way you do it, it should be times 26. And this is times 26. So our answer then is just 26 times 120, and it's 3,120 calories in many, many avocados, 13 avocados. And similarly here for 10, so we're going to take the rate we're given, 75 and 15. So 75 is the Sour Patch and 15 ounces. And then over here, you want to get to 7 ounces. We don't know how many candies. And then get a scale factor and go from there. So this has to get to X. This has to get to 7. So I always do the scale factor is the new one divided by the old one. You're pointing at the new one. So 7 in this case is the new one. 7 divided by 15 is that number right there. So this is times 0.46 repeating times 0.46 repeating. So I'm going to leave that on my calculator, and I'm just going to do times 75, and that will get us right to what we need, 35. It kind of copies and pastes it. 35 Sour Patch Kids. Down below, we can keep using proportions. So 75 to 15, Sour Patch to ounces. This one wants per ounce, which means 1 ounce. We don't know the number of Sour Patch Kids. So in this case, I might actually use division. 15 down to 1 is divided by 15. So if I just do 75 divided by 15, I will get the answer. This is 5. So 5 Sour Patch per ounce. A different way to do this is if you want Sour Patch per ounce, that tells you the order to divide. Divide your Sour Patch Kids by the number of ounces. Whereas the other one wants the ounces per Sour Patch Kid. So that tells us to take the ounces and divide it by the number of Sour Patch Kids. So we do 15 divided by 75, and we get 0.2 ounces per candy, Sour Patch Kid candy. Okay, or use a proportion. You can use either method here. It doesn't matter. For this one, if it's cost of one pepper, so you do cost divided by the peppers. So 639 divided by 3 would be the cost of one. If you ever want to find the cost of something individually, you always do the cost divided by how many. So 213 for 1. So 0 is going to be 0, 213 for 1. And I'm just going to keep scaling that up. So 213 times 2 would be 426. And then 213 times 4 is 852. 5 times 213, et cetera, et cetera. We just kind of keep scaling this up to get these other answers here. So I'm just going to fill in these just to save some time. All I'm doing is I am taking the 213 times each of these numbers to get the numbers down below. So the 7 should be 1491, 1704 for 8, 1917, and then 2130. And then the equation, I always do C equals because the cost is what makes sense to us. The cost of our peppers is our unit rate times the number of peppers. So the cost is 213 per pepper, which is what the equation is telling us. For this one, it wants us to first figure out the unit rate for 1 hour. So if it's 50 miles and 40 minutes, you want to get to 60 minutes, x miles. You want to use a scale factor to go from 40 to 60 and use that same scale factor up top. So again, I'm going to do the new one divided by the old. And we get this is times 1.5. So times 1.5. So 1.5 times 50 is our answer, 75 miles. So 0 is 0, 1 is 75. And then from there, I'm just going to keep doing 75 times each one to get the rest of this rate table. And that's how I'm filling these in. I'm just not showing it, but that's how I got these numbers. 75 times each of the hours to figure out all of these. And then for the equation, the miles we can drive is 75 for each hour. It wouldn't make sense the other way around. The hours we can drive is not 75 for each mile. That doesn't make any sense. We go 75 miles per hour. And then for our best buys down here, I always do the price per ounce. You can do it either way though. You could definitely do ounces per dollar. But if you do the price per ounce, you want the smaller option because it's cheaper. If you do ounces per dollar, you want the bigger option because you get more for $1. So I'll show it actually both ways. I'll show it for the first one. I'll do dollars per ounce. So dollars divided by ounces. So 149 divided by 8. So 149 divided by, let's try again, 149 divided by 8. So that would be about 18 cents, but or 19 cents. Don't round this because you want to see which one's better, and they might be close. 229 divided by 12 gives you, they are very close, 19.83. So see, the problem is if you call this 19 cents, you call this 19 cents, then they're the same, and they're actually not the same. The one on the left is a better deal because it is cheaper for 1 ounce. Whereas the next one, we're going to do the other way around. We're going to do ounces we get per dollar. So we're going to find the bigger number, whereas you wanted the smaller one the last time. So I'm going to do 12 divided by 1.12, and that will be the ounces per dollar because I'm dividing the ounces divided by the dollars. And that gives me 10.714285 repeating. And that's ounces per dollar. And the other one will be 40 divided by 379 and 40 divided by 3.79. Again, these are very close, 10.810 repeating ounces per dollar. So which one's better? The one you get more for your money. So in this case, we want to look at the amount we get a bigger number here. Oh, I think I missed the number. Hold on a second. Hold on, I missed a 9 when I typed that in. I was going to say, I think I had the wrong answer. Let's try again. So this is actually 10.55408971, and that actually changes the whole thing because this is now less. This is more for $1 or $1 like that, I guess. So this is better because it's bigger. We get more for the money, whereas the last one was better because it was less money for 1 ounce. So either way is totally fine. You just have to interpret your answer and make sense of it. Otherwise, you might have the full thing backwards. And that's the whole review packet for comparing and scaling.